one and all once again. So I think am I audible to all of you? If not, please message me the same. So we started with the model number 3. So first of all, we have understand the basic concepts of vibratory system. Then I have explained you the theory behind the free undamped single degree of vibrating system. Okay. Then we have seen a lot of different methods like energy method, Newton method. Okay. Now we will use all these basic concepts to solve the problem of a free undamped single degree of freedom vibratory system. Okay. So let's start with the problem. So first of all, you have a problem. So the problem is given in this manner. Determine the natural frequency of the system shown in the figure. Okay. Problem कसा असेल तुमचं बघा. Determine the natural frequency of the system shown in the figure. So the system is given here. So I will mark it as a system here. So this is the system. Okay. First of all, message me: is the screen visible to all of you? And am I audible? Is the screen visible to all of you?
Yes, sir.
Yeah. So this system is given. So this system is given, and they are saying that find the natural frequency omega. It means what? Basically, you have to find out the Fn. Okay. Now here, basically, they haven't mentioned any method. Like they haven't they are not expecting like determine the natural frequency of the system using Newton method or using energy method or using D'Alembert's principle or using Rayleigh's energy method. They haven't specified. If specified, you have to use. Okay. But if not specified, you can use any method which is suitable to you. I will be using an energy method, and I will be suggesting you to use the energy method unless and until not mentioned. Okay, because energy method is very simple because there is no need to draw the FBD. Okay, there is no need to draw the FBD. Obviously, I will be solving some problems on the D'Alembert's as well as the Newton method also. But a major of the problem I will be solving with the energy method. As I said, it is very easy, and no need to go for drawing a FBD, that is a free body diagram. Very important. Okay. Now what they have given. Okay. Now basically, first of all, try to understand that this is not given. Okay. This is not given. The problem is this much only. Okay. The problem is this much. Means what? They have given you the problem like this. But the problem kasa aseल? They'll be giving you some pulley. Okay. And let us say this pulley is given, and they are saying that this is a mass n here. Okay. And they are saying that this is a spring. Okay. This is a spring here. Okay, what is this? This is nothing but a K. Okay, and now the first point you have to understand that the center is fixed. Okay, this one is they have given. Okay, so this much is only given. This is actually a problem. This is the figure which you have to analyze. You have to convert this figure, right? Now what they are saying: determine the natural frequency of the system shown in the figure. Now, first of all, this system is at a rest condition. This system is at a rest condition. You have to make the system dynamic. Now, anybody, how will you make the system dynamic? First of all, okay. Don't look at this figure. Just focus on this figure. How will you make the system dynamic? You have to give some initial displacement, right? So let us give some initial displacement. I am giving some initial displacement. Let us say x. Okay. Now, x is the initial displacement given to the system. Now, what will happen? The first point you have to look that the center is fixed. Okay, the center is fixed. Okay, now when center is fixed, what exactly happens is that basically when this mass m, okay, mass m is displaced by x, what will happen to this pulley? Okay, let us say this is point number 1. First of all, I will call this as a point number 1. This point number 1 will shift to point number 2. Means what has happened? There is a displacement, angular displacement theta. Okay, there is an angular displacement theta. Means what? If x is the linear displacement given to the mass, x is equal to linear displacement given to the mass. Very important point. Try to understand. X is the linear distance or displacement given to the mass m. Okay. Because of this corresponding x, what will happen? Now this is a single degree of freedom system. This is a single degree of freedom system. Means what? Only one coordinate is sufficient to explain the complete or to specify the complete motion of the system. But again, we have here 2 or 3 coordinates maybe, so there will be a relation between these 2 coordinates. What is that relation that we have to calculate? So we will see that theta is the angular displacement of the pulley. Angular displacement of the pulley. Now this angular displacement means what? It is a rotational motion. It is a rotational motion. Guys, try to understand that whenever you are giving x as a linear displacement to the mass m, this x is nothing but the linear displacement. Means what? What is the motion of mass m? The motion of the mass m is translational. Because of this x, there's an angular displacement theta. In which direction? In this direction, because x is moving in the downward direction, so pulley will be pulled in a downward direction. So this motion will be in a which direction? Anti-clockwise. This motion will be anti-clockwise. So this theta is nothing but angular displacement. So the pulley will be having a rotational motion. Now corresponding to this k, now this k will also displaced by the x, because this k is connected to the mass m and the pulley itself. So the displacement of the spring will be also in the mass, also will be the displacement of the displacement of unit displacement of the spring will be also x, that will be in the upward direction. Is it okay? So this is happening. Now very important point you have to understand here, that I will rub out this all if you have understand. Important point is that when the center of the pulley is fixed, when the center of the pulley is fixed, okay, there will be no displacement of the CG. म्हणजे जर तुमचा center fixed नसता, तर what will happen? If whenever you are giving a x as a displacement, let us say this is the pulley, let us say this is the G of the pulley, what would have happened? What would have happened? This pulley will be like this. It would have become like this. Means what? The CG of the pulley would have been shifted by, let us say this is G double dash. So this is nothing but the x displacement. So x is the translational motion of a pulley. X is the translational motion of a pulley. Means what? The pulley is displaced at the CG. So when this pulley is means what? This point, let us say this is a G point, it would have come to this G dash. So this x is nothing but the linear displacement of the pulley. Means what? It will have a translational motion of the pulley. But in this case, your pulley is fixed at the center. Pulley is fixed at the center, so there is no translational motion of the pulley. So guys, I mean to say that this mass m will have only translational motion. This pulley will have rotational only if the pulley is fixed. But if the pulley is not fixed, this pulley will also have a translational motion. What is the translational motion? Its CG will get displaced by the x, since the pulley is not fixed. Because whenever you are applying a x as a small displacement in downward direction, this pulley will rotate by the angle theta, along with it will get displaced from the CG by the distance x. Now tell me, have you understand? Message me, have you understand the concept behind this? Have you understand the concept behind this, so I can start solving the problem? Yes, anybody? Hello, have you understand exactly what is happening if the pulley is not fixed? Okay, so try to remember that. First of all, you have to find out whether the pulley center is fixed or not. If the pulley center is fixed, there will be both motion, translational as well as the rotational motion. But if the pulley center is not fixed, sorry, if pulley center is not fixed, it will have both the motions, translational as well as the rotational. If the pulley center is fixed, it will have only a rotational, mass and will have a translation, and K is nothing but a linear displacement of the spring. Okay. Now let us start. So how will you start with the problem? So let us say point number 1, point number 2, and this is nothing but a theta. Okay, and this is nothing but x. So x be the small linear displacement distance given to the mass m. So pulley will rotate by an angle theta. Okay. Now let me draw this diagram. Now this diagram means what? What is this diagram? Okay. Let me consider this a triangle. Which triangle? Triangle this 0. Very sorry. Let me consider this triangle. Now this is actually a triangle, na? Okay. See, this is actually a curve. Basically, you try to understand that this is a curve, but since theta is very small, we are considering that theta is very small. Why theta is very small? Because we are giving a x as a very small linear displacement. So that is why instead of considering this is a curve, I can consider this as a triangle, a straight angle. Okay, straight line. So basically, consider this as a triangle. So let us say this is point as a 0, this is point as a 1, and this is point as a 2. Now this angle is theta. What is this distance? Let us say this is x. At point O, you are giving a small displacement x. Let us say, okay, means what? You are giving a small distance x, right? Now let us say that if this is a x, okay, what is this 0 to 1? This is r. What is 0 to r? Because let us say r is the radius of pulley, na? R is the radius of pulley. So this 0 to 1 distance and 0 to 2 distance is nothing but the r. Okay, then what is distance is 1 to 2? What is this distance 1 to 2? Okay, this distance will be obviously equal to x. Okay, because whenever you are giving a small displacement x to the pulley, okay, the distance traveled by this point 1 to 2 will be equal to x only, right? So this distance is x. Okay, now from geometrical figure, what we are getting sine theta is equal to opposite side upon hypotenuse. So what is opposite side? x upon what is hypotenuse r. So we are getting x is equal to r sine theta. But this theta is very small. Okay. Since theta is very small, we are considering sine theta is equal to theta. So x is equal to r into theta. Now, guys, try to understand that since this is a single degree of freedom system, we have to find out the relation between the x and the r theta, x and the theta. So, what is the relation between the x and theta? The relation is that x is equal to r into theta. Now, tell me, have you understand this relation? Now, if x is equal to r into theta, what is x dot? Velocity r into theta dot. What is x double dot? R into theta double dot. Here r is constant. Now tell me, have you understand this? Message me yes or no. Have you understood this? Analysis is very important, and this analysis goes on changing for each and every problem. So you have to apply the logic. Tell me, have you understand, guys? Message me yes or no. Message me yes or no. Okay. So this is very important. Now this figure. So what is the final analysis? X is equal to r sine theta. Since theta is very small, okay, I am considering sine theta equivalent to theta. So x is equal to r theta. So this is a very important relation what we have got, okay, from this geometrical analysis. So how I started? They have given you nothing. They have given you just a system. I have given a small displacement x. Since the center of the pulley is fixed, I have considered the rotational motion of the pulley only. So theta is nothing but since x is in a downward direction, theta will be anti-clockwise. Okay. So theta is the pulley will rotate by an angle theta. So I have considered it as a triangle. Here means a triangle also considered here. Why? Because 1 to 2 distance is very small. Because 1 to 2 distance is x. So this is also x. So 1 to 2 distance is very small. So instead of considering this as a curve, I have considered it as a straight line. So theta r x, I have got a relation. Okay. Now let us apply some method. Okay. Now first of all, according to the energy method, total energy is equal to constant. So Ke plus Pa is equal to constant. This is the energy method. Now anybody from your side, tell me what will be the kinetic energy? Okay, kinetic energy कोणा कोणाची असेल सांगा. Total energy method. Kinetic energy of whom? Mass, strain, pulley. Yes, tell me. How will you apply the kinetic energy? I have already explained you, na. So that
I
logic
theta
will.
dot square
No,
up
no.
I
Tell me
theta
first
dot.
of all kinetic energy of what? Mass, rotational, translational. First of all, write down the statement. Don't directly go for the formula.
Mass.
Kinetic energy of mass m. What? Translational or rotational? You have to first of all write down that.
Rotational.
Mass m. Kinetic energy of mass m.
Translational.
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 Translational small m plus kinetic energy of pulley. There will be the kinetic energy of pulley also, no? Because pulley is also having a mass capital M. They have given you the pulley of mass capital M. So what will be the kinetic energy of pulley M? Rotational or translational?
Rotational.
Rotational.
Rotational. Okay. And if the center was not fixed, if the center of Knox fixed, what would have become? The kinetic of pulley rotational plus translational, right? And now here the pulley is fixed. I will also solve the problem where the pulley is not fixed. Plus, now potential energy, that is strain energy of what? Spring K. Potential कोणाची असणार आहे? Spring K is equal to constant. So guys, this is the first and very important statement what we have to solve. Okay. So this statement I have written here. Ke of mass m translational plus Ke of pulley m capital M. See, sometimes they may not give you this m, so they may give you the I. Okay. So whatever is given, consider. Whatever is given, consider. Okay. Now they have given you mass m. Okay. Now 1 of mx dot square plus what is the kinetic energy? First of all, kinetic energy of mass translation. Anybody? How will you write the formula for this? Mass coordinate काय check करा. Mass coordinate काय? This x. So how will you write 1 of m into x dot square plus pulley 1 of I into theta dot square plus spring 1 of k into x square is equal to c. Now this is the statement what I have written. Okay. So here I have written 1 of mx dot square plus 1 of I theta dot square plus 1 of
Sir,
x into square.
I कुठून आला?
I is the mass moment of inertia pulley. I is the mass moment of inertia pulley.
Okay, sir. Okay, sir.
Mass moment of it is a standard beer. Okay. In the last lecture, if you are present, I have told you that if the given structure is disk, now this pulley is nothing but a disk. Na? For disk, what is I? What is I? Mass moment of inertia. How do you calculate? mr square by 2. Okay. Now here what is the mass? Capital M. So what will be the I? Basically I is nothing but the capital mr square by 2. This is standard what we have studied in the strength of material. See, in mechanical vibrations, we have to apply a lot of basics from the mechanics to this. Okay, so even if that I said that even if the I is not given, I is nothing but a mass moment of inertia. For the rotational system, we are considering I. For linear system, M. For rotational, I. For linear, K. For rotational, KT. For linear x dot, rotational theta dot, linear x rotational theta, x double dot theta double dot. This is what I have explained in the last lecture. Okay, chalo. So 1 of I into theta dot square. This is a rotational system. Na? Rotational means what? Torsional system. So always you have to write 1 of I into theta dot square. Theta dot is nothing but the velocity, angular velocity, plus 1 of k into x square. Okay, chalo. Now first of all, we'll put down all. Now what is? How will you solve this? 1 of m into what is x dot? What is x dot? R into
R
theta
theta.
dot square. R theta dot x is equal to R into theta. So x dot will be R into theta dot. Try to understand that. Okay? Try to understand it. So 1 of m into x, sorry, R into theta
Okay,
dot
sir.
square plus 1 of. What is I? What is I? I for pulley or a disc. I formula तुमचे लक्षात ठेवायला पाहिजे. स्लेंडर बार असेल तर ml square by 12. Sphere असेल तर ml square by 6. Square असेल तर ml square by 3. So I theta double I theta dot square. I काय येणार आहे? आता त्याचं मास किती आहे पुलीचं? कॅपिटल एम. सो कॅपिटल एम आर स्क्वेअर डिवाइडेड बाय 2 into theta dot square plus 1 of k into what is x? What is x? R into theta square is equal to c. Is it clear? Clear? So हे सगळं मी याच्यामध्ये पुट केलं 1 of r theta dot square plus 1 of I into theta dot square. I तुम्ही नंतर पुट केलं तरी चालेल. So I theta dot square plus 1 of k into r theta square is equal to c. Okay? So differentiating. Now differentiating with respect to time. Let's differentiate kara. Anybody? See, basically try to understand that you can put I here mr square by 2 or at the end also you can put I. So I will suggest you that you put I at the end, which will make your system easy for differentiating. So anybody, I will write down the differentiating 1 of m into r square, r sub bracket square, derivative of theta dot square. Anybody? Directly
2
will write.
theta dot into d theta dot upon dt.
Yeah, 2 theta dot into theta double dot. No need to write d theta dot upon dt. Just for explanation, I have told you. Directly write theta double dot because d derivative of velocity is nothing but acceleration. That is theta double dot. Okay. So theta double dot plus 1 of I into theta dot square, 2 theta dot into theta double dot plus 1 of k into r. What is the derivative of theta square? Derivative of theta square r into 2 theta into theta dot is equal to 0. Okay, guys. Now up till now you might have understand that since this is a single degree of freedom, I have to convert. Now see, आपल्याकडे काय झालं? आपल्याकडे दोन नोटेशन x आणि theta. Now it is a single degree of freedom system, so I have to convert either x into theta or theta into x, right? So how would have you done? You have either put x is equal to r theta or theta is equal to x upon r. So either you have to bring the system into the x coordinate or into the theta coordinate. But I will suggest you that always put x is equal to r theta because that makes it easy. I will also show you problem by putting theta is equal to x upon r. So basically you have to understand that in single degree of freedom system, here you have to either consider any one x or theta. Okay. So 1 of ml r square theta plus I. Okay. So all differentiating. So what will happen? 2 will get cancelled. Theta dot will get cancelled from all sides, and finally what you will get? You will get mr square plus I into theta double dot common. You can see here if you are not understanding. Here what is remaining? Mr square. 2 will get cancelled. Theta double dot plus. See, there is theta dot and theta dot is constant in all the terms. So it will get cancelled. 2 will get cancelled. Plus here I into theta double dot plus here k. Okay, r square will get also cancelled. No, r square will not get cancelled. So k into r square into theta is equal to 0. So from here again put theta double dot common. So you will get mr square plus I. Now remember that this m is very small. Okay, so theta double dot plus k square into theta is equal to 0. Okay, so this is happening over here. So same I have written here. So now you can see that mr square plus I theta dot plus k square theta is equal to 0. Now I am putting I. What is I? I is nothing but the capital mr square. Sometime they may give you that the mass of the pulley is small m. So what we will write here? mr square theta. Guys, try to understand that you have to look what is given. The mass of the pulley is capital M, small m, or let us say if it is not given at all, you will keep I as it is. You will keep I as it is because we don't know it is capital M or small m. Okay, or you can also assume it as a small m. You can also assume it as a small m. Okay, but I will suggest you that don't assume, keep I as it is. Okay, so now what will happen? Again, now r square is constant. So r square m plus capital M by 2 theta double dot plus k r square theta is equal to 0. Right? Now again r square will get cancelled. What will remain? Theta double dot. Now here what will remain? M into capital M divided by 2 theta double dot plus k into theta is equal to 0. Right? Now what we'll do? We will divide this term. Divide this theta double dot term by k. So what I will get? Theta double dot plus k upon m plus m theta 2. Okay. Now anybody, what is the next step? Final step in the derivation, compare with the standard equation of simple harmonic motion, theta double dot plus omega n square theta is equal to 0. Now comparing what you get, you get omega n square is equal to k upon m plus capital M by 2. What you are getting? Omega n k upon small m by m2, and what is fn? 1 upon 2 pi square of k upon m. You can write this like this also. Fn is equal to 1 upon 2 pi. You can cross multiply, so you'll get 2k upon 2 small m plus capital M. So this is your final answer. Now tell me, is there any doubt? Is there any doubt in your case? समजा कुठे काही doubt आहे का हा problem solve? This is a very very simplest problem. If you understand this, I can go for a complex problem also. So tell me, is there any doubt where you have a doubt or any term which you have not understand? Yes. I will move on to the next problem. Be fast to answer. Be fast to answer. Is there any doubt? No? Shall I go to the next problem? Hello? सगळ्यांना समजलंय? ओके. चलो आता next problem. Determine the M equivalent and K equivalent for the system shown in the figure. Now what is M equivalent? First of all, M equivalent is nothing but it's a combination of masses. Combination of masses. So let us say there are two masses, M1, M2, M3. So combining this all, you will get a M equivalent. What is K equivalent? K equivalent is nothing but a combination of spring, that is K1, K2, K3. Whether the springs are in series or parallel, you will get a K equivalent. Okay. Now they have told you to find out now basically guys, try to understand that omega n is equal to K upon M. You can write this omega n is equal to K equivalent upon M equivalent also. Means what? Natural frequency is a K equivalent upon M equivalent. So guys, if you find out M equivalent and K equivalent, from this you can also find omega n. The most you can say the advantage of this method is that to find out M equivalent and K equivalent, no need to differentiate. Very very important. There is no need to differentiate. So this is the next method which I will be explaining you here, that there is no need to find out differentiation. So this is the second method. In first method, what I did, I differentiated and I compared it with the simple harmonic motion, and I got omega n is equal to something that is K upon M in terms of K upon M. But this is the next method which is called as an equivalent method. This is called the equivalent method. There are some problems which are very very complex, and in such a complex problems where there are a lot of term involved, means there are a lot of K, there are a lot of M involved, it is very very difficult to differentiate. It is not impossible but difficult. So that we use the equivalence method. What is this equivalence method? You have to find out M equivalent and K equivalent. So without differentiating, how will you find out K equivalent and M equivalent? That is very very important. Okay. So let's start the system. So what is the system they have given you? They have given you mass M. Remember that this is not given. This is not given. Okay. This 1 point is also not given. 2 point is also not given. Okay. So this much problem has been given. And now what you can see that again, first of all, the center of the pulley is fixed. Okay. Now center of the pulley is fixed means what? The pulley will be having only a rotational motion, no translational motion. Okay. Now first of all, what is the step? let x is a displacement given to the mass m. So I'm considering x as a displacement to the mass m. Okay, so let us say x is a displacement given to mass m. Now if x is the displacement given to the mass m, what will happen? Anybody? This pulley will rotate in the anti-clockwise direction by theta. Okay. Now this k will be compressed, spring will compress by x, and this 2k spring will be extended by x. So see the direction, x in this direction, x in this direction, because applied force, that is F, that is x, is in the downward direction. So pulley will be rotated in this direction. So now I will remove this all. So let us say this is x, this is 1 point, this is 2 point. Why I have to always mark this 1 point and 2 point and this O point? Because it is easy to draw the triangle, and from triangle you will get a relation. So now first of all I will find out the relation. Now I want to answer from your side. So for relation I will take this triangle. What is this triangle? O, 1, 2. Remember that this 1, 2 is a curve. This 1, 2 is a curve if you look into this figure. But since theta is very, very small, x is also very, very small, I am considering this as a right angle triangle. Okay. So tell me, what is this distance O to 1? R. What is the distance O2 to R? What will be this distance 1 to 2? Since you are applying x at this point, okay, so this 1 to 2 distance will be also x. So what will be the x? Anybody? So what will be the x? Same. X का ऐसे R into
Sin theta.
theta. R into theta. Now directly write down. No need to. हे तुम्हाला समजण्यासाठी सांगितलंय. No need to go for sin theta equal to opposite and directly consider. Now you are just applying. Your aim is to find out the natural frequency. No need to go into the basic. So x is equal to r theta. X dot is equal to r into theta dot. This is what I've got. Okay. Now, so here I have shown this diagram. You can see x is equal to r theta. X dot is equal to r theta. So this is now done. Okay. Remember that this x will be displaced. K will be displaced by x. This will be displaced by x. I think have you understand how I am taking a direction? Take your direction according to this x. Okay. Chalo. Now according to the energy method, total energy equal to constant, kinetic energy constant. Now basically guys, whenever you are solving a problem by equivalent method, means what? You are finding a m equivalent and k equivalent. Separately find out Ke and separately find out P. Now I will not combine the kinetic energy and the potential energy. Why? Because I am not going to differentiate. Whenever you are differentiating, you are using this. Okay. So first of all, let us find kinetic energy. Now tell me what is kinetic energy. Forget about the potential. Anybody? Kinetic energy of mass? Small m. Yes. Kinetic energy of mass and what? Translational or rotational?
Translational.
Okay. Plus kinetic energy of capital M. Capital M means pulley. That translational or rotational?
Rotational.
Why not translational? Why not translational? Anybody? Why I'm not considering translational?
Center is fixed.
Yeah, pulley center is fixed. Good, very good. Okay. So this is very, very important part. Otherwise your answer will be wrong. Okay. So kinetic energy equal to kinetic of mass and translational plus pulley load. Now tell me what is the formula for this? Kinetic energy of mass and translational. One up. Anybody?
Mx dot square.
Mx dot square. For pulley, 1 up I into theta dot square. Okay. Now see here, I am solving the problem by the equivalence method. So I am considering kinetic energy separately. Okay. So now, first of all, what you will do whenever you are solving this problem by a equivalence method, remove half common. त्याच्यातनं half common काढायचं. So what is half common now? 1 up. Half common काढायचं म्हणजे काय काढायचं? 1 up m into x dot square plus I into theta dot square. Okay. Now, if you are removing a half common, put what is x? What is x? Anybody? Sorry, what is x dot?
r theta dot.
R theta dot. Okay, हे put करायचं. ही पण मेथड खूप सोपी आहे बघा. Okay, मग मी put केलं. 1 up mx dot square r theta. What is I? What is I? I is nothing but the mass moment of inertia of a pulley. I is nothing but the mr squared by 2. What is I? mr squared by 2. हे सगळं पुट केलं मी. आता पुट केल्यानंतर बघा कॉमन काय आलं याच्यातनं. परत theta dot square कॉमन निघाला. So 1 up and theta. So guys, very, very important that whenever you are solving a problem by equivalence method, you have to always remove half common in a bracket theta dot common. So 1 up and theta dot square is a common. So remaining term will be what? Your M equivalent. Is it clear? Whenever you are removing a 1/2 common and theta dot square, the remaining term in the bracket will be M equivalent. Now here I haven't differentiated anything. मी काहीच डिफरन्शिएशन केलं नाहीये. मी फक्त हाफ आणि थीटा डॉट स्क्वेअर कॉमन काढला. तर जो ब्रॅकेट मध्ये जी टर्म असते ती म्हणजे तुमची एम इक्विव्हॅलेंट असते. वाय? Why? Because the formula says that kinetic energy is equal to 1 of m equivalent x dot square. Because what is the formula for kinetic energy? 1 of mx dot square. Na? When it is 1 of mx dot square, anybody? When it is 1 of mx dot square, when m is single. But when the m is multiple, the m becomes 1 of m equivalent. So the formula is kinetic energy equal to 1 of m equivalent x dot square. So half common, x dot common. So remaining m equivalent is nothing but the m equivalent is nothing but what? M equivalent is nothing but what? So remaining is nothing but the m equivalent. So this formula can be written like this also. Like this means what? This formula can be written like this also. Kinetic energy is equal to 1 of m equivalent x dot square, or in torsional system this formula becomes 1 of I into I equivalent into theta dot square. So guys, only thing you have to understand that when it is a x, it becomes a m equivalent. When it is a theta dot square, it is a I equivalent, but both are one and the same. M equivalent असेल किंवा I equivalent असेल, one and the same. But just it's in the different system. One is in the rotational, one is in the translational system. Is it clear? Message me yes or no. Is it clear? This formula clear झाला. So this becomes 1 of m r square into m r square theta I theta dot square. Okay. Is it clear? क्लियर झाला तुम्हाला? ओके, इथपर्यंत क्लियर झालं असेल मी पुढे जातो. ओके, चलो नाव नेक्स्ट. ओके, ना मी कॉमन काय काढला, ह्याच्यातनं परत कॉमन काय लिहिणार? 1 of m r square plus capital M r square by 2. So r square is again the common. So remove r square common. So 1 of small m plus capital M by 2 r square into theta dot square. Okay, now basically guys try to understand. Now there is a change. Now what is kinetic energy? 1 of m equivalent into x dot square. Or what is the kinetic energy? 1 of I equivalent into theta dot square. Okay, now here it is theta dot square. So this in the bracket term will be what? Bracket term will be what? Means what? If I write like this, 1 of m plus m by 2 mr square plus mr square by 2 into theta dot square. So what is this bracket term? I equivalent. Why? Because the formula is kinetic energy is equal to 1 of I equivalent into theta dot square. But what they have asked, कधी तुम्हाला काय विचारले? I equivalent विचारले का m equivalent विचारले? Anybody? What they have asked?
M equivalent.
M equivalent. So
M equivalent.
So what do you have to do? Tell me. So formula कसा असला पाहिजे? 1 of m equivalent into x dot square. Okay. But here it is a theta. So this is I equivalent, but I don't want I equivalent. I want m equivalent. So guys, what you will do? We'll just use this formula. X dot is equal to r into theta dot. So what is theta dot? Theta dot is equal to x dot upon r. So you have to just put this theta. Means what? You have to convert this theta into the x dot. Why you have to convert this theta into the x dot? Because they have asked you m equivalent, but this is r equivalent because it is theta over there. So it is very very simple. You have to just convert. Convert म्हणून मी हा r square बाहेर constant काढलाय. Okay. So what is the formula? X dot is equal to r theta dot. So theta dot is equal to x dot upon r. So convert this 1 of 2m plus 2m capital 2. So cross multiply 2m plus capital M by 2. R square as it is. What is theta dot square? Theta dot square is theta dot is equal to x dot upon r. So theta dot is equal to x dot square upon r dot square. This r square will get cancelled. So what is the remaining? 1 of 2m plus capital M by 2 into x dot square. So what is this? Kinetic energy 1 of m equivalent to x dot square. So what is m equivalent? 2m plus capital M by 2. ओके, जर त्यांनी तुम्हाला I equivalent विचारलं असतं तर मी इथेच थांबलो असतो. माझं I equivalent काय आलं असतं? I equivalent equal to m r square plus capital R square upon 2. हा माझा I equivalent झाला असता. So have you understand the difference? Whenever you are finding a I equivalent, you are getting this term R square. But whenever you are finding this m equivalent, this R square gets cancelled. This is the difference. That is why I equivalent and m equivalent is different, even if both are in terms of a masses. Now tell me, here I haven't differentiated anything. Have you understand how I have found out m equivalent? Please message me. Have you understand or not? Is
Yes,
it
sir.
clear? Any doubt in this? Similarly, now find out K equivalent. What is K equivalent? Potential energy of spring 1. This is, let us say, spring 1, and let us say this is spring 2. Okay. So what is the potential energy of spring 1? Anybody? Potential energy of spring 1, 1 of K into, याचं डिस्प्लेसमेंट काय असेल? डाउनवर्ड असेल ना, एक्स. याचं कसं असेल? इकडे असेल. एक्सच असणार आहे दोघांचं डिस्प्लेसमेंट. ओके. सो 1 ऑफ के इंटू एक्स स्क्वेअर प्लस 1 ऑफ ह्याचे किती आहे? 2k into x square. Okay. Now guys, very important, try to understand that. Here I again, what is my formula? Potential energy is equal to 1 of k equivalent into x square or 1 of kt equivalent into theta square. आता मला सांगा, तुम्हाला त्यांनी काय विचारलंय? के इक्विव्हॅलेंट विचारलंय का केटी इक्विव्हॅलेंट विचारलंय? एनीबडी? व्हाट इफ आस्क यू? के इक्विव्हॅलेंट और केटी इक्विव्हॅलेंट?
K equivalent.
सो आय वॉन्ट टू फाइंड आउट के इक्विव्हॅलेंट. म्हणजे मला इथे एक्स पाहिजे आणि ऑलरेडी इथे एक्स आहे. सो नो नीड टू पुट एनिथिंग. इफ दे हॅव आस्क्ड यू केटी इक्विव्हॅलेंट, मग तुम्हाला या एक्स ला थीटा मध्ये कन्वर्ट करावं लागलं असतं. सो दिस इज अ सिंपल थिंग्स व्हॉट यू हॅव टू रिमेंबर. सो डायरेक्टली व्हेरी सिंपल. 1 ऑफ 2k plus k, x square common, 1 of common. So this is equal to 1 of 3k into x squared. So this is equal to 1 of k equivalent to x squared. So what is k equivalent? 3k. So in this way, I have got k equivalent and equivalent. Okay. Now they haven't asked you to find out the natural frequency, but if you know what is m equivalent or what is chi equivalent, try to understand that f omega n, that is a natural frequency. This is a new formula which I have explained, is equal to square root of n equivalent. Sorry, what is happening? Omega n is equal to square root of k equivalent upon m equivalent. Okay. Or you can also write omega n is equal to square root of kt equivalent upon I equivalent. So it is very important. If they ask you to find out kt or I equivalent, take theta as a parameter. If they ask you to find out t equivalent or m equivalent, take x as a parameter. And from omega n you can find out omega n from both k equivalent upon m equivalent or kt equivalent upon I equivalent. So guys, which method is easy? Differentiation method or this equivalence method? So what is omega equivalent? K equivalent upon m equivalent. Put k equivalent as a 3k upon 2m plus m by 2. So final answer you are getting 6k upon 2m plus small m. Yes, okay. Chalo. Now guys, tell me which method you have. It is easy for you. Differentiation method or equivalence method? I have explained you two methods. One is differentiation and second is equivalence. Which method is easy for you? You can use any method because from both the methods, but very important. If they ask you to find out m equivalent and k equivalent, there is no choice. You can find out, you have to use equivalence method. But if they ask you to find out the natural frequency, you can use any method, differentiation method or equivalence method. So tell me which method will be using? Equivalent. Okay,
Equivalent.
it's your choice. It's your choice. You use any method. Okay, but very important. You have to remember the formulas. Okay. So for today, I think these two problems are sufficient to you because the next problem is slightly a difficult one and I require more time for it. We have a very less time for this. Okay. So next problem, I will just give you the overview of this next problem. What is the next problem? See, now this next problem is slightly different. Now in this case, what they are saying, find the natural frequency of the oscillations for the roller rolling on the horizontal surface without slipping. The mass of the roller is 5 kg and radius 50 mm and stiffness of the spring is 2000 Newton per meter. Find the natural frequency if radius is 100 mm without changing. Means what? Now here it is very important that this is nothing but a roller. Okay, it is nothing but a disc, circular disc. Okay, so I will be what? Small m r squared by 2. It is given small m, but very important that this roller is rolling on the ground. It is rolling on the ground. So the contact point is P. So what I mean to say is that the instantaneous center is not O. The instantaneous center is P. मागच्या प्रॉब्लेम मध्ये काय होता? तुमचा सेंटर कुठला होता? Instantaneous center was O. Means what? If you draw this figure like this O was your point where you are getting a theta. That is 1 and 2. So O was your center where the pulley was having an angular displacement theta. But here in this problem, it's very important you have to understand that if P is the center. Means what? If the P is the center, okay, P is the center means what? this the angular displacement will be like this. Means what, if I draw the figure like this, okay, let us say this is the center point O. The pulley will rotate at this point. म्हणजे या पुलीचं रोटेशनल मोशन कुठल्या पॉइंटला होत आहे, दॅट इज युअर instantaneous center point. In last cases, the pulley was rotating by angle theta at what point? O point. But here the pulley will be rotated like this. Let us say that if I am giving a small displacement x to the center of the pulley. Okay. So what is this problem exactly? Let x is a small linear displacement given to the roller. Means what? I am giving a small displacement x to the roller. मग जेव्हा तुम्ही रोलरच्या सेंटरला स्मॉल डिस्प्लेसमेंट x देताय, what will happen? Now this pulley is not fixed. Guys, try to understand that this pulley is not fixed. It is not fixed. So what will happen? Anybody? What will happen? This pulley is not fixed. Means what will happen if I am giving a center displacement x to the mass n? So when mass n the center displacement data x, this center is not fixed. Means what will happen? This pulley will have both the motions, translational as well as
Rotational
the
and translation.
translational motion. Means what? Anybody tell me what do you mean by a translational motion? Let us
Linear
say-
motion.
Yeah,
Displacement.
means what will happen? What will be displaced? This is, let us say, point O. You will get a new point O dash. Means what? Your pulley will rotate always at a new center O dash. Means what? There is a displacement of the CG, na? So center will get displaced G to G dash. So G dash to G double dash. So this is nothing but X. Okay. R will not vary. R will always remain constant. That's the motion. Why R will vary? I am not changing the radius. Try to understand. I am not changing the radius. Why R will vary? I am not changing. No? See, I will show you the figure. What will happen? See, this is exactly happening. What is translation means? What? Initially, your center was here. The center went to the G dash. Okay. R is not varying. Only तुमचा काय होतं? CG डिस्प्लेस होतोय. जेव्हा तुमचा सेंटर फिक्स नसतो, या CG. Translational motion means what? The center of the pulley is displaced. Means what? Initially, the center of the pulley was G. After some time, it becomes G dash. What is the distance between the G and G dash? X. Why X? Because I am giving a small displacement X to the pulley. So have you understand the translational motion? Now tell me what is rotational motion in this case. Rotational motion means what will happen? Where the pulley will rotate by angle theta at point O or at point P? Where will the rotational
At point
motion
P.
at point P? So this is very, very important. Now you guys, you try to understand that I is equal to mr squared by 2 is the, you can say, mass moment of inertia at point O. But at point P, it is not mr squared by 2. So what is at point P? You have to apply the parallel axis theorem to find out IP. Because you have to consider IP, na? Why I use this is IO. What is IO? mr squared by 2. In last cases, I used IO is equal to mr squared by 2 because the center displacement at the O. But now you have to calculate first of all IP. And how will you calculate IP? By using the parallel axis theorem. Okay? Chalo. So that is next point. First of all, translational motion. What is translational motion? Whenever you are giving a center displacement x to the pulley at the O, the center will displace from G to G dash, and this distance is nothing but the x. Okay, so this is nothing but a translational x. Now, what is rotational? Rotational is nothing but this pulley center. Let us say this is point P. Let us say this is point O. This is point P. Pulley center will displace by x. Okay, so this is nothing but the theta. Okay, where is the x? This is nothing but the x. So pulley will displace by theta. Pulley will displace by theta. In which direction? Clockwise direction. Okay, असा displace होणार आहे ना तो असा theta clockwise मध्ये. Okay. Now, very, very important to understand that this distance is r. Let us say OP. What is OP? Anybody? What is OP? R. Let me call this point as a 1. Let me call this point as a 1. Now, anybody? What is this distance O1? Anybody? What is this distance O1? Anybody? O1 हे distance काय असणार आहे? काय असणार आहे? बघा ना, इनिशियली मी इथे होतो, O ला होतो, मी इथून 1 ला गेलो. तो O to 1 हे किती डिस्टन्स झालं? x झालं ना, कारण तुम्ही x हे डिस्टन्स कन्सिडर करताय. सो O हे डिस्टन्स तुमचं 1 झालं. इज इट क्लिअर? मग मी जर मी ट्रायंगल ड्रॉ केला, इथे, तर माझा ट्रायंगल कसा आहे? असा उभा ट्रायंगल आहे ना. This is very, analysis is very, very important. What is this distance? Theta. What is this point? O. P. And this is 1. So what is O21 X? And what is this R? Now tell me what is what is X? Anybody? What is X?
R tan
From
theta.
R tan theta नाही रे बाबा. R theta. Again. Don't R sin theta. It's basically R sin theta ना. हे पण Rच झालं ना. हे पण Rच झालं. T21 म्हणजे Rच झालं ना. So x is equal to r sin theta. Sin theta is equal to opposite side upon hypotenuse. R upon x. So x is equal to r theta because theta is very small. So again you are getting x is equal to r theta. आता मला सांगा हे तुम्हाला दोन्ही कन्सेप्ट क्लिअर झाले का? Is it clear? So see here. So this is try to understand that this is point P, this is point O, and let me call this point as a 1. Okay, so this is also r. So x is equal to r theta. Clear? Yes or no? Clear की नाही मला आत्ताच सांगा. दोन्ही मोशन झाले ट्रान्सलेशनल पण आणि रोटेशनल पण मोशन. इज इट क्लियर टू ऑल ऑफ यू? बी फास्ट. येस, व्हेरी गुड. चलो.
Yes, sir.
Now tell me how will you find out? Now let us say you know IO is equal to mr square by 2. Now first of all, how will you find out IP? You have to first of all find out IP. That is the mass mode of inertia at point P. Anybody? mr square by 2 plus yes anybody?
IO.
Means what? IO IP is equal to IO plus what? I plus m into h square
M.
distance. Now let us say this is point O, this is point P. What is the distance between the O and P? What is this is h? What is h?
R.
R. So IP किती झाला? IO किती आहे? स्मॉल आहे ना, बघा याचा m स्मॉल आहे, याचा मास त्यांनी स्मॉल m दिलाय म्हणून मी स्मॉल m घेतो. डोंट कन्फ्यूज. mr स्क्वेअर डिवाइडेड बाय 2 प्लस m into r स्क्वेअर. किती झाला IP? IP किती झाला? आता किती झाला IP? दोघांचं ऍडिशन करा ना. 3mr square by 2. So that is why if we use I is equal to mr square by 2, that is wrong theoretically. Practically that is wrong. Theoretically that is correct because since this theta is very small, try to understand that. आता मी तुम्हाला एक गंमत सांगतो. I is nothing but the IO is nothing but the mr square by 2, but I am interested in P, which is nothing but the mr square by 2. Now theoretically if we use mr square by 2 also, it is also okay because in books if you use a different books they neglect this IP. They neglect it because they say that the vibrations are very less because this is a free undamped system and vibrations are very less. X is very small, theta is very small, hence the oscillations are very small. So they are neglecting this IP and instead of using this mr square by 2, they are using mr square by 2 only in books. So that is also correct theoretically, but practically it will give you small different result. But theoretically it is correct because it is a free vibratory system. Okay, but I will suggest you that you will not go by the book method, you will be go by our method and you will be finding an IP because it will give you a more accurate result. But if you find out I by using mr square by 2, that is also correct. I have to give you the marks. मला तुम्हाला marks दिले पाहिजे because by book or by syllabus this mr square by 2 is also correct because they are neglecting this parallel axis theorem. Okay, but I will suggest you that you use this method. Okay, is it clear or not? Okay, now बाकी सगळं सिंपल आहे according to the energy method. पहिल्यांदा मला सांगा तुम्हाला कळलंय का? Have you understand this analysis? Which analysis? Translational analysis and the rotational analysis. And IP is equal to 3mr square by 2 हे मी कसं फाइंड केलं? पटकन मेसेज करा, आपला प्रॉब्लेम संपतोय 5 मिनिटात. Okay, चलो. So rest is easy now. Okay, rest is easy. चलो, kinetic energy of mass and translational बघा. Kinetic energy of mass and translational plus kinetic energy of mass m rotational. rotational आला पाहिजे कारण पुली तुमची आता इथे वेगळा मास m नाहीये, ब्लॉक मास नाहीये. It is only a pulley. So pulley is having a mass m translational plus pulley is having a mass m rotational plus potential energy of the spring. Okay, so solve. What is translational? Translational काय तुमची 1/2 mh dot square. Rotational काय? हा rotational आहे. 1/2 I theta dot square plus potential जो spin किती आहे 1/2 kx is equal to square is equal to c. X dots किती आहे r theta dot I theta dot square plus k into r theta square. Okay, सगळं पुट करा, सॉल्व. डिफरन्शिएट करा. आता मी डिफरन्शिएटिंग मेथड वापरतोय 1/2 2mr square theta dot into theta double dot plus I किती पुट केलं मी? I किती पुट केलं? 3mr square by 2. ओके, काही जण mr square by 2 पुट करते. That is also correct. Theoretically that is also correct. But I suggest you that don't go by this method. Book method. Okay, so 1/2 k square into सगळे तुम्हाला काय मिळालं? theta dot plus 2k by 5m upon t. So compare with the standard equation motion. So omega n is equal to 2k upon 5. आता त्यांनी तुम्हाला m दिले 50 kg, K दिले 2000 मीटर. रिमेंबर दॅट मास शुड बी इन द kg, K शुड बी इन द न्यूटन पर मीटर. हे सगळं याच्यामध्ये पुट करा. पुट केल्यानंतर तुम्हाला हे सगळं तुम्हाला दिलेलं आहे ना, मास आणि के. तुम्हाला एफ ओमेगा एन किती मिळाला? 4 रेडियन पर सेकंड. सो व्हॉट इज एफ एन? 1/2 पाय इंटू 4. सो 0.63 हर्ट्स.